Alright, the Railway Education Bureau, Instruction Paper Unit C1, Subject Electricity, Magnetism, Electrical Action, copyrighted 1945 by D.C. Buell. Electricity, Magnetism, Electrical Action, Introduction. This is the first draft text for the railroad employees who engage in electrical work, electrical apprentices, shop electricians, diesel maintainers, signal men of all classes, etc. must be understood that the principles of electricity and magnetism are working knowledge with arithmetic and formulas, some of the knowledge, certain principles, mechanics, physics, chemistry, are required in order to make practical shop use of principle of electricity and magnetism. Additional training is available to all students of the series electrical craftsmen. Also had sufficient training so they can read construction blueprints, circuit diagrams, wire plans, instructions, and these subjects is part of the training service. With the explanation, students of this service will realize some fundamental training offered to them with the mathematics, reading blueprints, sketching principles, mechanical drawings, elements, and mechanics are an essential step in their training. 5. As students advance in study with more difficult subjects, it becomes increasingly necessary for him to plan his study work systematically. It's far better to plan a study for 1/2 hour to an hour each day by trying to dissolve several hours to study one day and skip several days before proceeding. An hour each day gives a better chance to think over what is absorbed the day before, and consequently the knowledge gained will be retained. An irregular study is likely to cause the student to lose interest in the subject. 6. The adage, make haste slowly, applies to this work. Each paragraph should be read carefully, then reread, thinking. Each rereading may bring out some point escaped attention. Previously reading alone is not sufficient. Alright, where were we? In order to obtain real knowledge from the instruction, student must stop after each paragraph sentence, think about what he has read, the instruction carefully planned so that the student should be able to understand each step in succession after he has mastered the information preceding paragraphs or text. Failure to understand explanation. Any part of the text usually indicates that the student has failed to understand through some of the explanation preceded with the one that gives trouble. In such a case, the review preceding paragraphs usually will clear up the difficulty. In any event, should the student fail to understand any part of any of the text of the carefully studied, though, he is free to write with the Bureau the additional helpful explanation. 8. The first series of the text, Electricity and Magnetism, relate entirely to direct currents. Entirely separate series text gives instructions on alternating currents. When text series contains the practical formulas, problems pertaining to the subject under the discussion, explanatory problems are worked out with a demonstrated with the application of formulas carefully selected with the problem are given the examination questions required for the qualification of each text. Student should not terminate the examination question and endeavor to work the problems before he has really mastered the text. If he does, you will find that he has failed to obtain proper benefit of the study. Ability to study, solve the examination question is a sure proof of failure to understand some of the portion of the instruction indicate the necessity to do the review of the subject. Sources of electricity. 10. The most useful source of electricity are generators and batteries. Electricity produced with the chemical action ordinary batteries by a combination of mechanical magnetic actions in the generators. When produced, it's always a certain amount of voltage. Electricity, for the most practical purpose of electricity, must be considered a definite something which can be generated by a chemical action or by a combination of mechanical or magnetic action. When generated electricity has a finite purpose pressure that it is and has potential power to do work. Electricity can be moved from place to place and can flow as the current through the wire or other conductor. Potential power will be converted into the work of the motors, other electrical apparatus, or its potential power can be converted into the heat as in electrical iron. Electricity has many other practical applications. 11. Voltage. And the source of electricity is great deal similar to pressure steam boiler. It represents the potential power of the electricity. However, no electrical work produces except when the electricity flows through the circuit. Similar steam does not accomplish any work until it flows into the cylinder of the engine, a pump, or some other device where its potential power can be changed to work. 12. The storage battery is not a primary source of electricity. Electricity energy from outside sources used to charge a storage battery with the produce of the chemical change of the battery of the chemical action can be reversed by charging a large percentage of the electrical energy put into the battery during charging. Be reclaimed later as desired. 13. Dry cell furnishes electricity at a pressure of about 1.5 volts. Single cell storage battery furnishes electricity pressure about 2 volts. Generators can build up and produce electricity at a much higher voltage. Electrical pressure for lighting circuits of most homes are about 110 watts. Pressure in a long-distance power line may be as much as 50,000 volts or more. As an example, the storage battery used in a diesel locomotive usually is about 32 cells, so it operates on a pressure of 64 volts. Diesel main generator can furnish electricity pressure range about 1,000 volts. The diesel auxiliary generator supplies electricity at 74 volts to 75 volt circuits. 15 electricity can be moved from place to place, setting up a circuit through which it can travel. The voltage of the electricity which causes the movement of the copper wire provides one of the most practical paths through which to move the conductor electricity from place to place. 16. There are many metals besides copper through which electricity will travel readily. Electricity also travels with a number of the other substances which are not metals. Salt water in one example, carbon is another, moisture of the ground is another, and all substances are known as conductors of electricity. 17. There's a number of substances that which electricity will not flow. Slate, glass, mica, porcelain, some of the plastics, paper, scalp, rubber are examples. Such substances known as insulators, porcelain, and glass and plastic fittings are used to support power lines and other wires through electricity is flowing. These supports prevent electricity from leaking or short-cutting away from the path that is desired to have it flow. 18. Air is very good insulated. Bare wires that carry high voltage are strung out open air. When the bare wires are supported properly on insulators, are very likely electrical leaks or stray away from the path through the wires. 19. As long as a wire which electricity can be separated by a sufficient air gap and no insulation other than the air required to keep the electricity from jumping from one wire to another, where the wires must be strung close together, there is no danger of the air swinging together in the wind, touching because of vibration, and must be insulated. 20. Insulated wire is a wire that has been covered throughout the length of the coating insulation material sufficient to prevent any straying. A short circuit with electricity intended for the path of the circuit with many electrical connections are made by cables which contain as many separate conductors are required for the different circuits. Each wire and conductor of the cable converted sufficient coating in scalic, rubber, fabric, or other insulation to hold electricity intended circuit. 21. Understand how the electricity is moved and how it flows from place to one another. One first must imagine that there is a source of electricity, that is a battery or generator where supply electricity a certain pressure voltage is available to be used. Batteries and generators are provided with terminals to which the wires will form a circuit or connected. The terminals are marked positive plus for positive subtraction. Negative electricity flows through the source of the circuit back to its source. It's considered to flow from plus positive terminal through the circuit back to the minus negative terminal. Electricity will not move the flow except for the complete circuit. That means the wire or the conductor will form the lead connection. If the circuit must leave from the terminal of the battery or the generator through whatever path of electricity, it flows back to the original terminal of the battery or generator, so that there is no break in the circuit. If the circuit, though, through the electricity is moving is broken, the movement of the flow simply stops. Questions for self-examination. What is conductor electricity? What is meant by insulated? What is insulated wire? What is required to have electricity? Will there be any electricity through the circuit, and if a switch in the circuit is open? 23. Electrical energy is the potential power present with the air source. Electrical energy can be used to produce heat or work. With the magnetism, the common way to use electrical energy pass electricity through a circuit. Heat or magnetism to produce work is accomplished when the electricity overcomes the resistance that passes through a circuit. 24. Resistance. Anything in the circuit with retards movement of flow electricity through the circuit with a wire circuit often hinders to the free movement of flow electricity. Consequently, it offers some resistance. However, principal resistance in a useful circuit electrical equipment which is to be operated which produces heat and magnetism in performing its purpose. 25. On fundamental fact, most born mind flow electricity through resistance, no matter how much electricity is in a certain voltage is available to flow through the circuit. Only as much will actually flow, but the voltage can force through the resistance of the circuit. The voltage is increased, more electricity will be forced through the same resistance. If the voltage is reduced, less will flow. 26. An example of resistance where electrical energy is changed into useful work is an electrical motor, electrical iron. Example of resistance where the electrical energy is made useful by producing heat. A simple example of electrical light where the resistance of the filament of the greater filament becomes heated. Incandescent produces desired light. Or relay is example of resistance where electrical energy is made useful in magnetic action. 27. After electricity has been formed, all of the required work in the circuit must lead back to the negative terminal of the source. Return portion of the circuit must have the wire used for just one circuit. It may be common wire which forms a return for dozens, 100 different circuits. 28. Since the earth of the ground is a fair conductor, its use of the return path of some circuits, the bare end of the wire from the last resistance of the circuit should lead to the ground. When the path of the return circuit is through the ground out, one terminal is the source of all must be grounded. The path of flow of the electricity must be complete. 29. If there is a convenient metal path that can be used for the conductor return portion of the circuit, it will be liable for a ground alone, more reliable than a ground alone. Any return path is spoken as a ground return. For example, the rails track electrical streetcar lines are used this way. The metal frame of the automobile is used to return the circuits for the headlights and horn. Similar, the locomotive frame may be used as a ground return for some electrical circuits. One terminal of the source, that is, one terminal of the battery or of the generator, must be connected with a ground return in each case. 30. All circuit wires must be insulated with a ground connection. Electricity completed with the useful for the work circuit. Otherwise, electricity will short a circuit through the ground without performing the intended useful work. 31. When wires large comparison with the amount of electricity flowing through it, a very little heat will result from the friction of the passage of the electricity through the wire. With little heat formed will radiate air without being apparent to the touch. Even if the wire is covered with the insulation, the small amount of the heat developed dissipates through the insulation without evidence of the heating. However, a large quantity of electricity is being forced by voltage through the comparative small wire. Electrical friction will be sufficient to heat the wire in proportion to the resistance. May heat an incandescent to incandescent, as in the case of electrical light bulb. Electrical engineers know the experience how much heat each wire is able to dissipate without an appreciable increase in temperature. Designers of the electrical circuits therefore specify the size of wire each circuit will carry the necessary amount of electricity with undue heat. Alright, 33. Even the smallest wire carrying the highest voltage to the amount of voltage causing heat, the size of the wire must be proportional amount of electricity that it flows through. The questions are, what is electrical resistance? How is electrical potential power source of electricity used to perform work or produce heat? What is meant by a short circuit? What must size of the wire used in the circuit selected according to the resistance of the circuit? That is the amount of electricity that will flow through the circuit. Kinds of circuits. There are two principal kinds of circuits. They are known as series circuits and parallel circuits. The combination of two circuits are called a series parallel circuit. There are shunts in some circuits, and shunts will be discussed later. If one terminal of the battery is connected through the series of light bulbs, as shown in Figure 1, the light bulbs are said to be connected in series. The total amount of electricity flows through the circuit must pass through each one of the light bulbs in turn in order to complete the circuit back to the battery. If any one of the four lamps is removed from the socket or burns out, the circuit will be broken and all the other lights will go out. 36. With four light bulbs are connected in the circuit, as shown in Figure 2, they are said to be connected in parallel. The electricity enters the circuit and divides a part of the flow through each of the four lamps. A part of the electricity flows through each lamp and completes in the circuit battery through the common return wire. 37. When potential supply electricity and certain voltage available to flow with each branch of the parallel circuit, the full voltage will act upon each lamp and other appropriate apparatus each branch of the parallel circuit. However, the only much electricity that will flow through each of the resistant branch will allow to pass. For example, in the parallel circuit shown in Figure 2, each lamp will burn full voltage source, but only as much electricity will flow through each branch as each can pass resistance of the lamp into the branch. 3 light lamps are removed. The fourth lamp has no more electricity than it did when all the four were burning. The other 3 lamps were using still available. The fact that there is no effect of the remaining lamp, the resistance does not change, so it burns just as did before. 38, Figure 3, 38. Referring again to Figures 1 and 2 with the total resistance of the 4 similar lamps in Figure 1. In series in Figure 1, down the voltage acting on one lamp with the 1/4 of the voltage source, whereas the lamps are in parallel, each lamp is acted upon by full voltage of the source. On the other hand, series circuit, and the total amount of electricity that flows through the circuit passes through each lamp just as though 4 lamps were one big lamp having resistance equal to that of 4. However, the lamps are in parallel, 1/4 of the total flow of electricity passes any one of the 4 lamps 39, a combination of two circuits shown in figure 1 and 2 and shown in figure 3, the first pair of light series and second pair of lights in series for the two pairs of lights connected in parallel. There is an example of series parallel circuit. The total amount of electricity will enter the circuit and will be divided equally between each two pairs of lights that are in parallel. However, since the two lights of each of the pair of series, each light of each pair will receive about half the voltage of the main circuit. And then the question for self-examination: what is a series circuit? What is a parallel circuit? What is a series parallel circuit? Examination questions. And that was a quick read through the Railway Education Bureau Instruction Paper Unit C1, Electricity and Magnetism.